In the last segment, we talked about buffers, and that in order to have a buffer, you need a weak acid and its conjugate base. If you have a buffer, you figure out the pH according to the Henderson-Hasselbalch equation, and the value of the buffer is that it helps maintain pH constancy. Segment 12 begins here. If we have carbonic acid and hydrogen carbonate, is it strong, weak, or is it a buffer? Carbonic acid deprotonates, we get bicarbonate, so when we have the two of these, that's a buffer. Again, remember that bicarbonate doesn't fall out of the sky, that we would get that from something like sodium bicarbonate, potassium bicarbonate, lithium bicarbonate. Okay? Nonetheless, the Ka may be slightly different than the one on the other page. Just go along with it for the point of illustration. Take the Ka, negative log, we start at 6.4. Log of the conjugate base over the acid. Conjugate base is 0092. That goes in the numerator. Carbonic acid goes in the denominator. And we end up with 0.0092 divided 0.123465 equals, push log, 2.2. 2.2. Okay, so because we have way more base, we would expect the pH to go up. pH equals 6.4 plus 2.2. Our pH equals 8.6. Still too high for living systems, but it's not a bad place to start. If we have the 2, the dihydrogen phosphate hydrogen phosphate buffer starts closer to physiological pH. This one wouldn't be too bad. If we start at 6.4, 10 times the base as the buffer, 6.4 plus the log of 10, 7.4, which is just about perfect. Now, if the log of the conjugate base over the acid, if the amount of the conjugate base and the acid is equal, we call that equimolar, then the log of x over x, we don't care what it is, they're the same, is the log of 1, and the log of 1 log, is equal to 0. So what this means is that if we have equal amounts of the conjugate base and the acid, this drops out as 0, and the pH equals the pKa. Just like up here, if we have equal amounts, x over x, this becomes 0, and we start at 4.7. If these are equal, x over x, this becomes 0, and we start at 7.2. On this one, x over x, if they're the same, we don't care what it is as long as they're the same, log of 1 equals 0, that drops out, and we start at 6.4. So equimolar buffers are nice places to start our math. So pH equals pKa when the amount of acid and the conjugate base concentrations are equal. Log of x over x, whatever it is the log of 1, which is equal to 0. Okay, so what is the pH of equimolar acetic acid, acetate solution, concentration, blah, 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 because we don't care, it's equimolar. pH equals pKa plus the log of 0.0075 over 0.000075. That's the log of 1. pH equals pKa, negative log of the Ka, which is 1.8 times 10 to the minus 5th, which is equal to 4.7. Poof, done. What is the pH of equimolar phosphoric acid dihydrogen phosphate solution in which the concentration of phosphoric acid and dihydrogen phosphate is this value? We don't care. It drops out as 1. So pH equals pKa equals negative log of the Ka. pH equals negative log. I believe it's 3.1 times 10 to the minus 3. I think. Maybe it's a 4. I think that's a 4. Okay, so we're going to go with that. Okay, so 3.1 EE negative 4 log 3.5. Okay, not a good biobuffer. pH is too low. Okay, what is the pH of equimolar hydrofluoric fluoride solution? Blah, blah, blah. We don't care because it's going to drop out as 1. pH equals pKa plus the log of x over x drops out. pH equals pKa negative log of the Ka. On this one, I pulled it out of the table. 7.2 times 10 to the minus 4. 7.2 EE minus 4 log 3.1. Okay, so none of these would be good biobuffers because the pH is way too low. The ones on the other page are much better contenders. Acetic acid acetate, not a good contender. Dihydrogen phosphate, hydrogen phosphate would start at 7.2. That's pretty good. Carbonic acid hydrogen carbonate, 6.4. That one's the best so far. But our ultimate best is if we have a carbonic acid hydrogen carbonate, which has 10 times the amount of conjugate base as acid, which gives us almost the perfect 7.4. Okay, so with that, that is our Unit 5. Do homework problems, Blackboard exercises as directed. There should be a plethora of videos. There should be more homework. There should be things on Blackboard, and there are ample problems in your book. Practice, as always, and the more you practice, the better this will be for you and the more confident you will feel.